Most people still think of cars as machines that mostly use energy when they move. You press the accelerator, fuel gets burned, the car goes somewhere, and when it's parked, most of that activity should basically stop. EVs don't really feel that way once you've lived with one for a while, and you start noticing little things that don't really match the way most of us think about cars. You park the car in the garage, walk inside, and an hour later, you can still hear fans running. Or maybe you wake up the next morning and the battery percentage is slightly lower than when you parked it. Sometimes the car starts conditioning itself before you even leave for work, and maybe the cabin is already warming up while the vehicle is still sitting in the driveway plugged in. None of those things feels dramatic individually, but after a while, you start realizing the car is doing things even when you aren't driving it. And honestly, I think this is one of the biggest mental shifts for people coming from traditional gasoline vehicles because most of us spend our entire lives thinking about cars in a very mechanical way. The engine runs, the transmission shifts, fuel gets burned, and heat gets created. And when the car is parked, the machine is mostly asleep. Modern EVs don't really operate that way anymore, and they behave much more like active systems that are continuously trying to maintain themselves in the background while also being ready to drive at any moment. And once you start viewing the car that way, a lot of confusing ownership experiences suddenly begin connecting together. So let's take the garage example. A lot of owners have walked into the garage after parking and heard cooling fans still running underneath the vehicle. The first instinct is usually that something must still be on because most of us are used to thinking of cars in a very binary way. The car is either operating or it isn't, but EVs often continue managing temperatures long after the drive ends, and that matters more than many people realize because temperature affects most everything the vehicle is trying to do. It affects charging performance, it affects how much power the battery can comfortably deliver, it affects regenerative braking behavior, and it affects long-term battery health. The entire vehicle is constantly trying to keep the battery inside conditions where all of those systems are operating consistently and predictably. The battery isn't just a storage container sitting under the floor. The vehicle is continuously trying to maintain an environment where the battery can perform efficiently without being stressed unnecessarily over time. And that management continues even while parked. You might notice this especially in more extreme weather. In colder temperatures, for example, some vehicles may continue protecting or stabilizing battery conditions after the drive ends. In very hot weather, the vehicle may continue cooling systems after parking, and sometimes the owner walks away assuming the car is off while the vehicle is still actively managing temperatures underneath. And over time, you start realizing this same pattern shows up everywhere else in EV ownership too. You see it during short trips. You get in the car and on a cold morning, turn the heat on, back out of the driveway, and within a few minutes, the efficiency already looks terrible. The strange part is that the drive itself barely even started yet. You're not driving aggressively, you're not flying down the interstate, you're just heading to work or driving a few minutes to run a few errands. But before the drive has even really settled in, the vehicle may already be warming the battery, conditioning the cabin, and stabilizing temperatures across different systems, preparing components to operate efficiently and predictably. And all of that takes energy. If the drive only lasts 10 minutes, the vehicle may spend a huge percentage of that trip simply trying to get itself into a stable operating condition before the drive is even meaningfully underway. Then the trip is over. That's one reason short local drives can sometimes look surprisingly inefficient in an EV, especially in cold weather. The startup and conditioning costs get spread across very few miles, so the efficiency numbers can look dramatically worse than people expect. Then something else can happen that feels kind of backwards at first. You finally get out onto the highway for a longer drive, and suddenly the efficiency starts improving. Intuitively, that doesn't seem like it should happen because highway driving absolutely uses more energy. Aerodynamic drag rises dramatically at higher speeds, and EVs are definitely not immune to physics. But now the vehicle has settled down. Battery temperatures stabilize, cabin conditioning becomes more consistent, and the drivetrain stops constantly transitioning between operating states. The startup energy costs that looked huge during a short trip now get distributed across a much larger distance. And once you notice that pattern, other ownership behaviors start making more sense too, like regenerative braking. A lot of people notice that regen can feel weaker on colder mornings or immediately after starting the car. Some assume something is malfunctioning, but often the vehicle is simply limiting how aggressively energy gets pushed back into the battery until the system reaches conditions it's more comfortable with. Again, the vehicle is managing itself in the background. The same thing happens when charging. People often think about charging the way they think about filling a gas tank. You plug in and energy goes into the battery, and that's basically the whole story. But charging performance depends heavily on battery temperature and systems preparation. In some vehicles, the car will actively prepare the battery before arriving at a fast charger because the battery accepts energy much more efficiently within a relatively controlled thermal range. So before the charge session even begins, the vehicle may already be using energy preparing for it. And after a while, you start realizing something important. A modern EV is almost never truly inactive the way most people think. Even while parked, the vehicle may be monitoring temperatures, balancing battery conditions, protecting long-term battery health, preparing for charging, or conditioning the cabin. And all of this is stabilizing systems or maintaining readiness for the next drive. That's why EV ownership feels mentally different from traditional gasoline ownership. Gasoline engines waste enormous amounts of energy too, especially during warm-up, but most of that behavior stays hidden from the driver. You don't usually watch fuel consumption changing in real time. You don't directly see thermal management happening underneath the vehicle. So you don't feel power availability subtly changing as temperatures move around. EVs expose much more of the system behavior directly to the owner. So you see efficiency changing constantly, and you watch projected range move around while you do. You notice charging speeds rise and fall, and you feel regenerative braking behave differently depending on conditions. Over time, you become much more aware that a vehicle is continuously doing things beneath the surface whether you asked it or not. And because all that feedback is so visible, some people interpret the behavior as inconsistency. But most of the time, the vehicle is behaving exactly the way it was designed to behave. Because the car isn't simply using stored energy to move down the road, it's continuously using energy to maintain the entire system around the drive itself. That's why your EV is often working much harder than you think. This is Wrench and Reason, where we explain how modern cars actually work. So thanks for watching, and I'll see you in the next episode.